All right, let's dive right in and plug into the very nervous system of smart buildings, KNX. Today, we're going to unravel the surprisingly simple tale of two addresses that keeps everything, and I mean everything, working together without descending into total chaos. So just picture a massive skyscraper for a second. You've got literally thousands of devices. Lights, blinds, HVAC systems, sensors, you name it. How on earth does a single button press know exactly which 50 lights to turn on? And how does the whole system not just collapse into a jumbled mess of commands? Well, that is the fundamental problem KNX was designed to solve. And the solution? It's actually incredibly elegant. KNX gives every single device not one, but two different addresses. Think of it this way. One is a physical address, like where you live, and the other is a functional one, kind of like being part of a group chat. So, let's start with the physical map. Okay, first up, the physical map. The whole idea here is pretty straightforward. You just give every single device its own unique identity based on its exact location in the network, and we call this its individual address. Now, a single KNX system can handle, get this, over 65,000 unique devices. That is a huge number. So to manage that kind of scale without it becoming an absolute nightmare, the entire network is organized into a really clear hierarchical structure. Let's think of the whole system as a city, right? We can call that the domain. You've got a central backbone line running through it, and branching off of that, you can have up to 15 major districts, or what we call areas. An area could be something like an entire floor of an office building. Okay, so let's zoom into one of those areas. Each of these districts has its own main street, and then branching off of that, you can have up to 15 smaller side streets or lines. A line might be what connects all the devices in, say, a specific conference room or a single office. And then finally, on each one of those side streets, you have the houses, the devices themselves. You can hook up as many as 256 individual components to every single line. So this layered, city plan approach is exactly what keeps a massive network perfectly organized. And what's really cool is that this physical layout is directly mirrored in the device's individual address. It's a 16-bit number, and it's structured just like a postal address. Area, then line, then device. So if you see an address like 1.2.5, it's telling you, clear as day, that it's device number 5 on line number 2 in area number 1. It's perfectly logical and totally unique. So if we look under the hood, that 16-bit address is broken down perfectly. The first 4 bits are for the area, which gives us our 15 options. The next 4 bits are for the line, giving us another 15 options. And the last 8 bits identify the specific device, which is where we get the 256 possibilities on each line. The physical map is the digital address. Simple as that. Okay, so every device has a unique physical ID. That makes sense. But, and this is a big but, that alone is pretty much useless for actual automation. You really don't want to switch to have to send out 20 separate messages just to turn on 20 lights. And that's where the second half of our story comes in, the functional link, which uses group addresses. You see, those individual addresses are absolutely essential for the installer, for setting up the system, configuring a specific device, or maybe running some diagnostics. But for all the everyday tasks, they're just not efficient. They're built for one-to-one or unicast communication. It's like making a direct phone call to just one single device. And this is where group addresses completely change the game. A group address isn't tied to a physical device. It's tied to a function. It's a shared address that acts like a virtual wire. Any number of devices can listen to or send messages to that exact same group address. This is what enables something called multicast communication, which just means sending one single message to many, many receivers at once. So a single switch can send one turn-off command to the office lights group, and every single light that's subscribed to that group just, it turns off. It's incredibly efficient. And just like with individual addresses, the capacity here is massive. A KNX installation can have up to 65,535 different group addresses. That's 65,535 different potential functions, from a good morning scene to a meeting room projector down. And it can link any device to any other device, no matter where they are physically located. So let's just put it all together and really look at the core difference between the physical map and the functional logic of KNX. So you've got the individual address, right? That's purely for management. It's a one-to-one unicast message, your unique street address for a single house. Then you've got the group address, and that's for all the day-to-day action. It's a one-to-many, multicast message. And the perfect analogy is a group mailing list, where one email reaches absolutely everyone on the list instantly. So you might be asking, why go to all this trouble? Why have two separate systems? Well, it turns out that this duality is precisely what makes KNX so incredibly powerful and robust. This whole separation basically gives KNX three superpowers. First up is efficiency. Using multicast group addresses keeps the network traffic low and super fast. Second, flexibility. A device's function is completely separate from its physical location. A switch on floor 1 can easily control a light way up in the penthouse. And finally, scalability. Because of this really clear organization, the system is just as easy to manage with 10,000 devices as it is with 10. And there you have it, the tale of two addresses, a physical map for identity and a functional web for communication. This two-part system is the absolute bedrock of every KNX system out there. It makes me wonder, though, now that you see how it all works, what's the first group function you'd create? Maybe a movie night scene or a single goodbye button that just shuts everything down. Thanks for tuning in.